So in previous lessons, we learned about the distance around a circle is called the circumference. All the way around the circle would be 2 times pi times r, or pi d. Well, what if we don't want to go all the way around the circle? What if we only want to go a portion of the way around the circle? That is called arc length. Now, in the previous units, we've talked about arc measure. So arc measure, if you remember, there were several things that we learned about arc measure, but the main one that's important to us is that in this case that theta is equal to, the angle is equal to the arc. Okay, remember that one. That's arc measure. When it says arc measure, your answer is in degrees. When it says arc length, what I actually want to know is how long is it? If I walk around the circle, how far do I actually walk? This is a distance. Okay, arc length is a distance measurement. Arc measure is a rotation. Okay, so that's the difference. So you need to know that because of the notation of how these questions are written. So arc length is a distance. So I want to know how long, how far do I walk if I walk from A to B compared to the distance all the way around the circle. And so we set this up as a proportion. So I have 360 degrees in the whole circle, and I want to use theta. I only want to use that part of it. And then I have the entire distance around the circle, or the circumference, but I don't want that whole thing. I want to go around part of it, and we usually use S. You can use any variable X, whatever you want there, but typically arc length is S. So if we look at this problem, arc length of AB, so I want to know how long AB is. So we just plug in our proportion. So I'm using 88 degrees out of 360 degrees. So how long is the length of AB if the entire length all the way around is 2 times pi times 2? So you go through. You can cross multiply, or you can do 88 divided by 360 equals 2 times pi times 2. And you get that the arc length, in this case I called it x, is equal to 3.07. Sometimes you might be asked to leave it in terms of pi, so you would do 88 times 4 divided by 360. And that's 44 out of 45. Most of the time, if we ask you to leave it in terms of pi, it's going to be like kind of a whole number, or a little bit prettier than that. So arc length of AB, so I want to know how long AB is. I want to know how long this piece is. So I use 97 degrees out of 360 degrees. And I set that equal to the part that I want, x, over the entire distance, which is 2 times pi times r, which would be 8 pi. 2 times 4 is 8, so 8 pi. So you would do 97 divided by 360 times 8 pi, and you get 6.77. So the arc length is 6.77. Just to give you a comparison, the entire distance around 8 pi, which is the entire distance is around, is 25.1. So 97 degrees out of 360 degrees is 6.77. So the distance around would be 6.77 feet versus 25 feet. 3.07 meters versus 4 pi, which would be 12.6. So you can see kind of how they compare, how those numbers compare. Now, for number 3, here's the difference with number 3. Number 3, I'm asking for the arc, the measure of the arc. Well, if I'm asking for the arc and it's central, then what I'm really asking for is what's theta. That's really what I want to know, is what is theta, because I'm asking for the degrees in the arc, not the length of the arc, but the degrees of the arc. And so what I want is theta, so I want theta out of 360. So what part of the circle, what angle of the circle do I use if the arc length is 38? See, this is labeled in feet. The arc length is 38 divided by the entire length around, given that the radius is 12.3. So it'd be 2 times pi times 12.3. So I would do 38 times 360 and divide that by, now when you divide, be very careful with this. If you type this all in all at the same time, then you need to type in 38 times 360 divided by 2 times pi times 12.3. Okay, all of that needs to be, if you divide by 2 pi, it always has to be in parentheses or you will get the wrong answer for sure. So be sure you put that in parentheses. So you get that theta is 177 degrees. Okay, so if I ask for the measure of the arc, that's like asking for the angle. If I ask for the length of the arc, that's a portion of the circumference. So I want to know the circumference, and this time I know the arc length. So we use our theta, which was our angle is 60 degrees out of 360 degrees. My arc length is 3.44 centimeters over my entire circumference. And so instead of 2 pi r, I'm going to use c. I could go ahead and find the radius from there, but it just asks for circumference. So you would do 3.44 times 360, and then divide that by 60, and you get that the circumference is 20.6 centimeters. So the distance all the way around is 20.6 centimeters, and the distance of that little arc is 3.44 centimeters. So for number 5, if arc, I want to find arc DE if the radius is the length of the arc. So it says to find the length of the arc, round to the nearest hundredth. So DE if the radius is 2. So if the radius is 2, I want to know how far the length of this part of the circle. Well, it's 120 out of 360 degrees. So I want to know the length of the arc, S, if the radius is 2. So that would be 2 times pi times 2. So you type that in, 120 divided by 360, multiply that by 4 pi, and you get that the length around of that portion, 120 degrees of that size circle, is 4.2 meters. So then the next part asks for DEA. DEA is this major arc all the way around. So that would be 120 plus 90. That's 120 plus 90 degrees. So you would have 210 degrees out of 360 degrees. And that equals the arc length that I want over, and this time the diameter is 7, so I'm going to use pi d. So I would use 7 pi. I always write 7 pi instead of pi 7, just because 7 pi looks like what we're accustomed to seeing. So if you cross multiply that, 210 times 7 pi divided by 360, you get that the length of that arc is 12.8, and that would be in inches. Okay, so that is arc length. Let's continue to look at this. The length of the arc is 12 pi. So the length of the arc is 12 pi, and it has an 80-degree central angle. What is the radius of the circle? So in this case, we have 80 degrees out of 360 degrees is equal to, this time we know the length of the arc, so we know 12 pi over 2 times pi times r. So you can start simplifying, but basically what you want to do is you want to do your cross multiplication. And so if you cross multiply, then you would get 2 times pi times 80 is 160 pi is equal to 360 times 12, which is 4320. And this r is right there. So you divide both sides by 160 pi, okay? And that should be pi 2. I knew there was something missing. And so my pi's cancel out, so I do 4320 divided by 160, and you get that the radius is actually, let me back up. It would be, 160 pi, so you do 4320. Sorry, double check. And you get that 27. So the radius is 27. Now you can use pi d if you want to, and then you just have to remember to divide by 2. So you just have to pay attention to whether you're solving for the diameter or the radius. So number 8, Lucy has to buy a new wheel for her bike that has a diameter of 20 inches. And I always like to have a picture just because it helps me to remember what's going on. If the bike wheel is rolled along the ground so that it rotates 45 degrees, how far will the wheel travel? So we want to rotate 45 degrees. So the question is, how far will the bike go if it has rolled, if the wheel has rolled that much? Well, it translates to your distance on the ground. So it's 45 degrees of 360 degrees. So the question is, how far is it going to roll if it has rolled, if all the way around it rolls 20 pi, which is pi d, right? Because you can use pi d, you can use 2 pi r, you can use circumference, whatever you need to, whatever version of it you need to use. So when you roll that around, you're going to get that S is equal to 7.85 inches. So if you roll 45 degrees, you're going to go 7.85 inches forward. If the bike is rolled along the ground for 10 inches, through what angle does the wheel rotate? So this one we're working backwards. So I want to know theta, and it's still out of 360 degrees, and it has rolled along the ground for 10 inches, which means that that's also, like if there was paint on the wheel, then the paint on the wheel is going to leave that line on the ground, and they're going to match. So it's 10 inches divided by, and it wants to know through what angle, and it's the same pi d, so we can still use 20 pi because it's the same size wheel. So you do 360 times 10 divided by 20 pi. Be careful here, it's 3,600 divided by 20 pi. If you don't use parentheses when you type that in, you're going to get it wrong. If you do 3,600 divided by 20 pi, like this, it will be wrong. You have to use parentheses, or you have to do it in 2 pieces, divide by 20 and then divide by pi. Either way, you get that your theta is 57.3 degrees. So just around to the nearest tenth. All right, the last one. You can't see it very well, but this is 160. This angle is 160, and this angle is 185. So that's what you can see. So the chain of a bicycle travels along the front and rear sprockets as shown in the diagram. The circumference of each sprocket is shown. How long is the chain? So we know that from here to here is 10, and we know from here to here is 10. What we need to find is how long is this piece and how long is this piece. Well, we know that those orange pieces are a portion of the circumference all the way around. So if we find, let's find x first, and then we'll find y. So to find x, it's 160 degrees out of 360 degrees. And so we want to know how far is it, how long is that chain, if the entire distance around is 12. Okay, you don't have to do 2 or pi or r or anything because I already told you what the circumference is. So you do 12 times 160 and divide that by 360, and you get, well, I called it S and I called it X, so I'm using different variables. Let me fix that. So X is 5.3 inches. Okay, then to find y, we do the exact same thing. On that side, it's 185 out of 360 degrees. So how long is that piece of chain if the entire chain of all the way around that wheel is 20 inches? So 20 times 185 divided by 360 is 10.28. So y is 10.28. So this is 10.28. And this is 5.33. So if you add 10 and 10 and 10.28 and 5.33, you get that the chain is 35.61 inches long. Okay, so arc length is a portion of the distance all the way around, which is circumference. And you set up a proportion. The angle divided by 360, the part over the whole, is equal to the part of the arc, the length of the arc over the